Hello, welcome students. You are watching chemistry subject on property of gas. Okay. So this is my third topic of this chapter. So here today I will discuss on the numerical problems on the basis of Boyle's law and Joy's law and the gas equation. Okay. So I have written three questions on the whiteboard. So let's do what the question given on the whiteboard. So let's see question number one. Here, what volume will a gas occupy at 740 millimeter pressure, which at 1480 millimeter occupies 500 cc, temperature being constant. So you must keep in mind that when the temperature being constant, this means that in this case Boyle's law is applicable. Okay, and you know very well that the Boyle's law is stated that the pressure of a gas is directly proportional to the so it is inversely proportional to the volume of a gas when the temperature remains what constant. Okay, so how can we solve it? Let's see. First of all, we have to see that what is given in the question. Okay, so according to a question given, this is the first case. First case means what volume will a gas occupy at this. Okay, so this means that this is the initial case. I mean initial what volume. Okay, initial volume say V1 equal to how much question mark. Okay, and initial pressure, initial what pressure, this means P1. Okay, how much 740 millimeters. So this is the initial case. Okay, and this is the second case. Here the final what final pressure is given here, and this is the final volume. Okay, so final volume, I mean V2 equal to how much 500 cc. Okay, and final what pressure, final pressure, I mean P2 equal to how much 1480 millimeter. Okay, so here the temperature being what constant. So we know from what Boyle's law, from Boyle's law. Okay, so what is the formula? P1 V1 equal to P2 V2. Okay, so we have to put the value of P1 V1 and P2 V2. Okay, so whatever unknown constant, unknown quantity, we have to find that. Okay, so P1 is how much 740 millimeter into V1, that we have to find. V2 how much 500 cc, and P2 is the 1480 what millimeter. So you have to see that when you turn it a lowest term, then millimeter that is struck off 740 multiplied by 2 equal to how much 1480. So this will also struck off. So in this way we get the volume how much 1000 cc. Okay, so this is the initial case of the volume of gas is how much 1000 cc. Okay, and next is the question number 2. A gas cylinder having a capacity of 20 liters. This is the question is given here that a gas cylinder having a capacity of 20 liters contains of a gas at 100 atmospheric pressure. How many flasks of 200 cc capacity can be filled at 1 atmospheric pressure? Here the temperature remains what constant. Again, when the temperature remains constant, then we have to apply a Boyle's law. Okay, so now first of all, in case of cylinder and in case of what flask. Okay, so initial pressure P1, initial pressure how much 100 atm. Okay, and volume is I mean initial volume, initial what? Volume V1, how much? 20 liters, okay. And this is in case of flask, okay. So in case of flask, that is the final volume, okay. Final what? Volume. That means V2 equal to how much? Final volume equal to 200 cc, and final what? Pressure. Here 1 atmospheric pressure, okay. And you have to find the number of what? Flask, okay. So here you have to keep in mind that in case of the volume of cylinder, here is 20 liter, okay. And here flask, in case of the volume, in case of flask, the volume how much? 200 centimeter cube, okay. So you have to must keep in mind that here the liter, you must convert it into centimeter cube. So what can you do? You have to multiply by what? 1000, and you get what? Centimeter cube, okay. So now you have to follow, we know from what? From we now Boyle's law, applying formula, we know, okay. That means we know from Boyle's law, okay. Boyle's law, P1 V1 equal to P2 V2, okay. But in this case, you have to find the number of what? Flask, okay. So I have written here n into P2 V2, clear? So now P1 how much? 100 atm multiply 20 cc equal to n 200 cc, okay. This is the volume, okay. Atmospheric pressure. Now this is atmospheric pressure cut off, or centimeter cube also cut off, okay. So then by calculating you get the number of what? Flask, okay. So this means that uh, number of what? Flask. How much? 10,000 flasks can be filled at 1 atmospheric pressure, okay. Clear? So in this way you will get the value of the number of flasks, okay. Now in this third case, here the question given that a certain amount of gas occupy a volume of 50 liter at 27 degrees Celsius, okay. And you have to find the temperature of the gas which has a volume of 100 liter. So here in the first case you see initial volume, okay. Initial volume, that means V1 how much? 50 liter, okay. And here final volume how much? 100 liter, okay. And here initial one? Temperature, this means T1 how much? 27 degrees Celsius. And you must keep in mind that in case of the property of the gases, I mean the Boyle's law or Charles' law or gas equation, you must convert the degree Celsius into what? Kelvin, okay. How? By adding 273, okay. So we have to add 273 by 27, and you get how much? 300 what? Kelvin. 300 Kelvin, okay. Now, sorry, 300 Kelvin, okay. Next is find the temperature of the gas. I mean, this means that you have to find out the final temperature, okay, of the gas. Here, so you must keep in mind, we know from Charles' law, okay, from Charles' law, V1 by T1 equal to V2 by T2. Now you have to put the value of this, and you will get the value of T2, okay. So given how much? 50 liter. T1 is 300 Kelvin. Here 100 liter you have to find out. Okay. So now liter struck of 50, this is 100 and I will 2, and in this way you get the value of what? Final temperature how much? 600 Kelvin. Now this Kelvin is again changes to what? Degree Celsius. Okay. So 600 minus 273 what? Degree. Okay, Celsius. So you will get 327 degrees Celsius. So in this way you get the final temperature. Okay. So in this way you can do by applying the formula Boyle's law, Charles law and gas equation. But today I have written the question on the basis of the gas equation. So next class we will solve it. So again hope you will understand very easily, and you have to do it at home. Okay, make practice. Have a nice day. Bye bye.